Hello and welcome to this fifth video in our lecture on remote user authentication. In a previous video, we described a secure protocol for Alice to authenticate herself to Bob. Bob would send a challenge, a random number R, which is called a nonce, and then Alice would send back a response that would be the hash code of her password concatenated with the nonce. And so for that technique to work, first there had to be a hash function, and second, both Alice and Bob had to know the password, which is not really a password if both people have to know it. It's not really secret. So instead of using passwords, we're going to switch to keys, and instead of hashing, we're going to switch to encryption. So let's assume that now we're using symmetric encryption. So Alice and Bob are going to have knowledge of a shared key. Let's call it K subscript AB since it's known to both Alice and Bob. And now Alice is going to authenticate herself to Bob using this key. And so she's going to have to prove to Bob that she knows the key, and she's going to have to do that without the attacker Trudy being able to discover what the key is so she can't impersonate Alice later on. So there's a very simple mechanism to do that. Again, it's a 3-message protocol. First, Alice sends her identifier to Bob. Bob generates a nonce, sends that random number to Alice as the challenge she has to respond to, and her response is going to be the encrypted version of the challenge obtained using the symmetric key. She's going to send that response to Bob, and of course Bob is going to be able to decrypt this response using the shared key. Is going to be able to recover the plaintext, which was the random number, and check that that number matches the challenge that he sent to Alice. And this is how Alice is able to authenticate herself to Bob using symmetric encryption instead of hashing. So notice another difference in this protocol is that in the previous video, we had a hash function here, and the hash function doesn't take a key as input, so it only took one input. And that input, if you remember, was the concatenation of the challenge, the random number, and Alice's password. Whereas here with encryption, the encryption algorithm takes 2 arguments, namely the plaintext, in this case the challenge or nonce, and then the key that is used for symmetric encryption. So this is the new scenario we're dealing with from now on. And so we're successfully done the authentication of Alice to Bob. Now, something that we need in many scenarios is what we call mutual authentication, where it's not enough for Alice to authenticate herself to Bob, but Bob is also expected to authenticate himself to Alice. And this protocol does not do mutual authentication. So how about we try to do the following thing? Because both Alice and Bob know the shared key, then Bob should also be able to authenticate himself to Alice using that key, the same way we just explained Alice can authenticate herself to Bob. So here is one way that we could try to do this. Alice is going to send her identifier, and she's also right away going to send a random number or a nonce. And then remember that the assumption here is that both Alice and Bob know a symmetric key, and only they know that key. So Bob is going to be able to get the challenge that Alice sent him, is going to be able to encrypt it using the shared key and send that back to Alice. Notice this is exactly what we did before. It's just the reverse. In this case, Alice is challenging Bob and Bob is responding. So in these 2 messages, then Bob is authenticated to Alice because he was able to take the nonce and encrypt it, and Alice was able to decrypt it. So this is a symmetric situation where Bob, in this case, authenticates himself to Alice, and there's no replay attack possible because of the random number that's involved in that exchange. Now we want mutual authentication, so of course we want also Alice to be able to authenticate herself to Bob. But that's not a problem because Alice, knowing the shared key, can also use it to authenticate herself to Bob. So why doesn't she also encrypt the challenge with the shared key, send that to Bob, and that would authenticate Alice to Bob, symmetrically to the way Bob authenticated himself to Alice. So, what is wrong with this protocol? What is the big problem here? Well, the problem should be pretty obvious that these two messages are exactly the same. They both encrypt the challenge with the shared symmetric key. So clearly, the second message cannot be of any use when it comes to security, in particular when it comes to authenticating anybody to anybody. Notice um, there's really no authentication of Alice to Bob in this case because whoever was on this end of the communication could have simply forwarded the message they just received and send it back to the original sender. So clearly, there is no mutual authentication here. This first attempt at mutual authentication is clearly not going to work at all. So in the next video, we're going to discuss a better version of this protocol in an attempt to enforcing mutual authentication.